All right, guys, welcome to distance learning. Today it's going to be what do the graphs of quadratic functions look like. Do me a favor, and if you haven't already done so, just print these notes out from the website. I'll give you a minute to do that, and then we'll get going on this. All right, so let's just do the do now together. Using your graphing calculator, go to your y equals and type in this equation, y equals x squared plus x minus 3. And just take a minute and hit graph and see what these things look like. All right, if you need more time at any point, obviously just pause the video and do what you need to do. But if you look at this curve, it's going to be, it's going to look like a sketch kind of coming down here. And then it kind of comes up and it looks like this. So these types of functions are very different than linear functions, and they're also very different than exponential functions. They almost have a U shape. Now we said sketch, which means it doesn't have to be perfect. You just have to get a general picture of what these things look like. All right, so our job today is we're going to start graphing a few of these things just to kind of see exactly what they look like and how we can go from there. So again, the equation must be in standard form. That's y equals ax squared plus bx plus c. Again, the value of a cannot be 0. The value of a cannot be 0. If a is 0, then this whole thing disappears, and you would be left with a linear equation. So a is not allowed to be 0. We're also going to find the x-coordinate of the vertex. We're going to talk about what the vertex is. It's also known as the turning point, and we have a nice formula, x equals negative b over 2a. And then lastly, we're going to create the table of values together using 3 values smaller than the vertex and 3x values larger than the vertex. And then we'll graph this thing and see what it looks like. So here's what I want you to do real quick. I want you to take our first example, and I want you to type this into your y equals. It's y equals x squared minus 2x plus 5. Again, how do I know this is quadratic? Because the x is to the second power. So go ahead and pause the video, type this into your y equals, and then just get the table of values ready, and then we'll fill this out together. All right, so the first thing we want to do is we want to identify what A, what B, and what C are. Now remember, A is the number before x squared, so A is going to be 1, B is going to be negative 2, and C is going to be 5. The reason you want to get those values is because we want to start off with finding the x value of our turning point. So we're going to use our formula x equals negative b over 2a. We can find that up here. And then we're going to substitute these values in. So it's x equals, I'm going to switch pens. So it's going to be x equals negative 2. So that's going to become positive 2. And we know the value of a is 1. Again, the opposite of b, so the opposite of a negative 2 is positive 2. And that's going to give us x equals 1. So we want to put that value right there in the middle. And here's what I want you to do. Whenever you find that, that's where the turning point is. Again, when you look at quadratics, they go down, they hit a lowest point, and then they start to go back up. Or they could be upside down, which we might see in the next example. All right, so now we're going to pick the 3 values that are smaller than 1. So we're going to pick 0, we're going to pick negative 1 and negative 2. And then we're going to pick the 3 values that are bigger than 1, 1, 2, 3, and 4. Now take a minute, go back to your table of values since you already typed this in, and fill in all the y values. Again, these are functions, right? Numbers go in, and then numbers come out. Numbers go in, numbers come out. So take a minute and just fill that chart in. All right, so you should get these values, 13, then we get 8, and then we get 5, and then we get 4, and then it starts to go back up, 5, 8, and then 13. Okay, so this point here, since this is the x value of 1 that we got before, that means that 1, 4 is called our turning point. Another word for the turning point is the vertex. So it's also called our vertex. This point right here. So I know that our U shape is going to kind of turn at this location. So you might say, I'm having a problem. I can't graph -2, 13. My graph doesn't go high enough. And that is totally okay. You do not have to graph every point unless there's a restricted domain. In these cases, we are not doing restricted domains. So let's call this y, and this is our x-axis. So I'm going to start with -1, 8. Go ahead and start graphing these points as I do it. And again, I can't graph 4, 13 either. But if you notice, it makes a U shape. So what we're going to do is we're going to connect these with a smooth line, or as smooth as we can get it. So here we go. We're going to I like to come up from one side and kind of go just a little bit past it. You don't want to go too much past it. Some people even stop on the last point, because then you might aim it in a direction that it really doesn't go. So try not to go too much past the last point, and then kind of come up the other side here and kind of graph that as well. So there you go. We have our first kind of U shape. We call these parabolas. And again, just like any function, we are going to label the equation on one of the arrows is usually the best way to do it. So this is y equals x squared minus 2x plus 5. All right? Good. So here's what I would like you to do. I would like you to start this next one. So go ahead and type this one into your y equals. And then start to figure out what values we're going to use here. So you're going to have to go through the vertex turning point using the formula, and then you'll get your middle value, and then we'll figure out values on either side of that. If you need to pause the video, take a minute and do this, and then we'll go through it together. All right, so I'm going to start off with x equals -b over 2a. And again, the value of a is -2. Just like we did with the quadratic formula, we identify a, b, and then c. So then we're going to have -8 over 2 times -2. -8 over -4 is +2. So I know that our turning point is going to be at 2, something. Now, take a minute and fill in the rest of the chart. Again, you get those values right from going to your table of values. So we're going to choose 1, 0, -1, and then 3, 4, and 5. So if we fill this in from our table of values, you get -9, 1, 7, 9, 7, 1, and -9. All right, so this point here is really important. This point, that is our turning point. Otherwise known as what? Anybody? All right, I guess I'll do all the talking today. This is 2, 9. It's called our vertex. It's where the parabola is going to turn. So let's go ahead and plot these points and get a general kind of shape of what's going on here. So we have -1, -9. So let's see if we can even reach that. 1, 2, 3, 4, 5, 6, 7, 8, 9. Perfect. We have 0, 1, which is right here. 1, 7. 1, 2, 3, 4, 5, 6, 7. 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. 3, 7 is going to be right here. 4, 1 is here. And then 5, -9 is going to be down here. Now, what do you notice about this one is that it kind of opens up downwards as follows. So let's graph this. Try to be as smooth as you can. This one kind of looks like it's upside down, and we're going to talk about that in just a second. Let's just label our axes real quick. And again, we label our graph y equals -2x squared plus 8x plus 1. Do you notice that the graph kind of goes up? It's increasing, and then once you get to our highest value, it starts to go back down. It's where the graph will turn. Do me a favor and then hit graph and just see a picture in your kind of 10 by 10 window frame and just make sure that this is what it looks like. All right, awesome. So let's take a few notes. So go to the next page. This is going to be our last page together. I'm just going to throw this up here, and then we're going to just go through this real quick. All right, so the parabola opens up. What do I mean by opens up? I mean it kind of points up so that the arrows are pointing up. If it opens up, that means that the A value, the leading value, is going to be positive. So that's going to be a positive value. But if it opens down, which kind of looks like this, kind of opens down, that's going to happen when the A value is negative. So if we just quickly flip back here, our first example, what was the A value? The A value was 1, which is positive, and it opens up. In our second example, the A value is negative, and it opens down. What that negative does is it actually reflects it, so it kind of flips it upside down. So that's our first note there. Next, if the parabola does open up, then the vertex is called a minimum, which is also going to be our lowest point on the curve. And if the parabola opens down, then the vertex is called a maximum, which is going to be our highest point. And lastly, the vertical line that divides the parabola into two equal halves through the vertex is going to be called the axis of symmetry. The axis of symmetry. Make sure I got enough ink. All right. So what we're going to do is we're going to go back to the first two graphs. So we're going to label the axis of symmetry and the vertex, and we're going to state if there's a minimum or a maximum. So let's just go back and do that together. So here we go. This vertex of 1, 4 is going to be a minimum because it's the lowest point on our graph. As where this turning point of 2, 9 is going to be called a maximum, since it is the highest point on our graph. And then lastly, we just want to sketch the axis of symmetry. Again, the axis of symmetry is nothing more than a vertical line in these two cases that will cut the parabola into two symmetric halves. Symmetry means it's the same on both sides. So if I just go right down through here, this line, might be able to make that a little darker here. Let me use a different color. This line here, which by the way is x equals 1. Remember, all vertical lines are x equals a number, so this is our axis of symmetry. You might hear us say AOS, axis of symmetry. So then on either side of this line, they're equal halves. And the axis of symmetry here is a line that comes right down the middle. And this is x equals 2, which is really what we get from over here, because that's going to be the point, the x value of the point where this thing turns. So that is our axis of symmetry there. All right, so what you guys have are 6 problems to try on your own. I highly advise you try these 6 problems. The answers to all 6 of these are on the website under homework section. Just be mindful, we want you to create a table of values, graph the parabola. I would use graph paper. If you don't have any, do the best you can to sketch it neatly. Label the vertex, determine if it's a minimum or maximum, graph and label the axis of symmetry for each graph. So basically go through the same steps we just did for all 6 of these. Also, please make sure you go onto Castle Learning. There are 10 questions there today that we can just check in to make sure you watched the video and you kind of understood. Other than that, if you have any questions, please email one of us, check out the answers to these, and then we'll see you tomorrow for a new lesson. All right, see you guys later.